Some say that science is what scientists do. Not sure if we're quite there yet. Science is a historical enterprise, and it's developed over the ages, and there are still some expectations of what science would involve. It's what we often call the scientific method. In its most basic form, it is simply that you define a problem, you ask a question, and you come up with answers. And there are those answers we often call hypotheses. And we may have several working hypotheses, several working answers, and then we develop those into what might be called a theory, where they're much more well-defined and much more logical. Then the second step is we take that answer and we test it. Matter of fact, if we talk about what is the key difference in modern science from ancient philosophy, it's that we took our ideas and rather than just logically arguing for them, we actually looked at the world. We looked at how nature and reality works and see if it actually fit with our ideas. It's a process called experimentation. And so we form theories and then we test theories. Science is often divided into those two categories. Those scientists that form theories, that come up with answers, we call theoretical scientists. And those who take those answers and test them, we call experimental scientists. And they involve different reasoning processes. The science actually progresses the way we progress, by taking one step and then the next step, right foot, left foot, right foot, left foot. Well, science also does that, but the reasoning processes are induction and deduction. Induction is the process used in theory formation and theoretical science. That's where we take an understanding of a few samples in a group and we draw a conclusion about the group as a whole. We generalize. That's induction. You've probably heard the term stereotyping. Many times if we stereotype someone, it's based upon this process of induction. We take a few experiences we've had with a few individuals and we superimpose that upon the group as a whole. And so we take our limited knowledge and we infer what may be based upon that. That's how we develop theories. And then the second step is theory testing, experimentation, and that involves another reasoning process called deduction. And it's just the reverse. It's where we take a general knowledge, a knowledge of the group as a whole, and we specify something about one of the members of the group. And so in doing so, we can progress, so to speak, in the scientific method, developing a theory and then testing that theory. And so if we came up with, let's begin with an induction. I saw several college students who were wearing striped socks. So I could take that and draw a generalization from that. All college students wear striped socks. And then we could take that general understanding, that question, or the answer to the question, the theory, and we could test it. I go into a college, I look at the student who's sitting in the library, and I say, that student, even though I can't see his sock, I know his socks will be striped because he is a college student. And then we make a prediction from that. That student will have striped socks. We pull up their pants leg and we do an experiment. We test our prediction from our induction, our theory. And the student doesn't have striped socks. The student has red socks. And so we can either get rid of our theory and come up with a new one about polka dot socks or pink socks or whatever, or in most cases in science we can modify our theory to fit the new data. And so we modify our theory. All college students wear striped socks except for those in the library. When they go to the library, they put on their red socks. And so we now have a more elaborate theory that incorporates the new data, and we can use that through the deductive process to come up with another prediction and go to another library or the cafeteria or something like that and do another experiment. And so if we go into the cafeteria and we find a college student, he shouldn't have red socks on, he should have striped socks because he's in the cafeteria. We do the experiment, we lift the pants leg, and voila, he has striped socks. Well, we just made a correct prediction from our theory. Doesn't mean our theory is true. We know it's probably not true. But it does add a certain amount of plausibility to the theory, and as science progresses and more predictions come true, then that begins scientists thinking maybe there's something to this theory, and eventually the theory becomes accepted. So we move from a hypothesis to a theory to an accepted theory. Matter of fact, we can actually look at science as a whole as a progression in terms of something becoming more and more probable. So you begin with the uneducated guess, a hypothesis, which moves to a more widely accepted hypothesis we call a theory, and then eventually the theory gains pretty conclusive acceptance throughout the scientific community. And at the point that that theory that's widely accepted by the scientific community begins to hinder other answers, certain theories will not be even entertained because they don't fit into that particular theory. We have another name for that in science. They call that a paradigm. Paradigms or perspectives. There's ways of seeing the world that would rule out other things. So when Columbus goes to the king of Spain and asks for a ship, or the queen, I can't remember if it's a king or queen, when he goes to the Spanish monarch and asks for ships to sail west to arrive in the east, someone who believed in a flat earth would say, that's not a valid theory. We can't accept that theory because when you sail west, you fall off the edge of the earth. You don't get to the east. And so there are certain paradigms, there are certain widely accepted theories that will rule out even the consideration of other theories. We call them paradigms. Whenever there's enough evidence to show that that paradigm is false and another theory gains acceptance, that's what Thomas Kuhn called a scientific revolution, where our whole perspective about the way the world works changes. We've been through several scientific revolutions through the history of science. First was the geocentric universe, where the Earth was the center of everything, to the heliocentric solar system. We put the sun in the center. We also have paradigm shifts in biology, from special creation to biological evolution. You have paradigm shifts, revolutions in science, in the science of geology. From catastrophism, the world was shaped by a series of catastrophes over a short period of time, to uniformitarianism, where the Earth is shaped by everyday process acting over vast amounts of geologic time. You also have physics paradigm shifts, from Newtonian physics to Einstein's view of the universe. And so the thing is, the history of science shows there's been several radical revolutions that have occurred in fairly recent order. During a paradigm shift or a scientific revolution, very oftentimes it's not that there's necessarily new data, new information, but that the way of perceiving, the way of seeing the data has changed because we have a different model. For instance, in this image you can see that we have data, we have information on the page. Light areas, dark areas, gray areas, lines, curves, and so on. However, our mind will superimpose an answer to the question of what is this. Some of you may see an old woman. That's the old woman theory. Others may see a young woman, the young woman theory. And so we can take the same information and we can superimpose two completely separate models upon that. And so if you look at the feature near the bottom of the image, it looks like the old woman's mouth, but in the young woman theory, the mouth becomes a necklace. And so the same information can be interpreted in two separate ways. You could take the plausibility to its maximum, and we would call that a natural law. They're so widely accepted, and they've been so widely accepted for so long, that we consider it as something that is just the way the world works. So we might have the law of gravity. You go up on the top of your house, you jump off, and you expect to fall down. It's very plausible you'll fall down because everyone seems to fall down. But there is that possibility that you could fall up. I wouldn't chance it, but it does demonstrate the fact that even natural laws have a certain aspect of probability, and the fact that we don't really know as human beings what the future holds.